So I'll give this to you. And so yeah, welcome to CSCI 41. Hopefully you're in the right place. If you've never taken a class with me before, I want to tell you that I don't make my presentations full screen, so it's a little bit smaller than it could be. I'm sorry, but I'm going to be flipping around between a bunch of different pages. And also I get really cool pens this way. I get the rainbow pen, which you do not get in full screen mode. So look forward to that. So do that. And in addition to the recording, I'm going to give you all the slides as a PDF and all the code that I write today and for every other lecture on Canvas. So don't feel like you have to write every little thing down. You can sit back and relax a little bit more than usual, unless you feel like that helps or something. You can write everything down, but you're getting this one way or another. And so yeah, I like to run my lectures like a discussion. So feel free to just shout out if you would like to ask a question, derail me at any moment. I am here for you. So yeah, this is my plan for the day at least. I would like to at least introduce myself a tiny bit in case you've never met me before. We'll do the boring stuff. We'll talk about the syllabus very, very quickly, as fast as I can do it. And then we'll go over like a short intro to the class, like what we're going to learn. And then we'll try to get ourselves up to speed in C++. This should be a review. I'll go over like classes and structs and stuff that you should know from 40, but maybe it's been a summer, right? So we'll get us all back to where we need to be. Okay, so if you need any kind of refresher, I also made this little, it's an old video, but it still is applicable, this optional lecture 0. Go click on that if you'd like and watch it. But yeah, that's the plan for today. Let's start with me. I'll have one slide about myself. So hello everybody, my name is Lawton Nichols. I use he, him pronouns, and I like to say this every semester. I will respond to whatever you would like to call me. You can say Mr. Nichols, you can say Dr. Nichols, you can say Professor Nichols, whatever you like. But honestly, I'd prefer it if you just dropped all these and call me by my first name. Please call me Lawton. I want to earn your real respect. I don't want your fake respect from these titles, okay? Yeah, so call me Lawton if you'd like. And a little bit about my background is I went to Fresno State for my undergrad, and then I transferred to UC Santa Barbara for grad school. I have every degree you could possibly get in computer science, and hopefully that means I know something and can teach it to you, okay? We'll see over the semester. We'll find that out together. And yeah, a little bit about just me personally is like I like to be a human as well. I like to go running. I like to play guitar. I like to dance. I have a swing dancing lesson tonight, actually. That'll be fun. Come to Fresno Swing Dance if you would ever like to learn that. Wonderful people. And I also have a cat. I like to cuddle with him as well. This was him as a kitten. His name is Alonzo. I named him after Alonzo Church, who you should totally look up his Wikipedia page. He's a very cool guy. Did a lot of very nice things. He also, in addition to all the other nice things, he was the advisor at Princeton of Alan Turing, whose name you should definitely know by now. All right? Sad life, but great stuff and accomplishments. So yeah, that's a little bit about me, and we also have an embedded tutor in the class. So if it's okay right now, could you please introduce yourself?
It's Caitlin. I'm your embedded tutor. You've been to CSCI 40 semester, you might remember. So as your embedded tutor, I'm gonna be class and I'll be any questions. So throughout the year, I'll be making study sessions with all the students for review purposes. I'm also working at the tutorial center. I'll share my hours sometime. Here, as a SCCI student, you are given free tutoring, so it would be great if you took advantage of that at the tutorial center. You can get help in CSCI 41, but also all of your other classes as well. A bunch of resources that we give out for free. It would be really amazing if you could come down to these.
Thank you, Caitlin. So yeah, take advantage of the tutorial center, you guys. It's the greatest place ever. If you haven't been there yet, it will save your life. And we have Caitlin here as a liaison. All right. So yeah, I think that's most of what I wanted to introduce. So just like I like to have this slide as well. Just like thank you in advance for putting up with me throughout the semester. We'll get through it together. We live in these trying times. It's very hot outside, etc., etc. We will survive. We have curtains this semester. This did not exist. It used to be huge, horrible glare. So just You guys should already be thankful, right? So yeah, let's get through the boring stuff now. And like I said, shout out if you have any questions. I'll get to them. I just want to go quickly though, just so that I stay awake and you do too. All right, it's your job to read that syllabus. So this is an in-person class. This is actually the first time I've taught CSCI 41 in person. Things have been switched around. It's exciting. So here are the rules, I guess. What's going to happen is I got to take attendance. We'll deal with that in a second. I'm going to do it at the start of the lecture from now on, but I'll show you the way that we're going to do it. All right. And do not trust whatever Canvas says for the times that we're having lab. All right. The way that I run my classes is whenever I'm done talking and the lecture's over, that's when lab begins. That's how that's going to work. All right. And you are allowed to leave the lab part at least whenever you're done with all the stuff I've assigned. All right, so you don't have to stay and keep the seat warm if you're done with everything. And that's kind of the rules that I will impose, I guess. Okay, as far as dropping you goes, if you don't go to the first lecture, you're all here today, so you won't get dropped, but anybody who didn't come to the first lecture, I'm required to drop. And then my drop policy going forward is going to be if you miss 3 classes in a row, that means you've stopped coming. All right, and then I will also drop you. So I mean, I can excuse an absence if you're sick or something. You just got to tell me, all right? So keep that in mind. That won't count towards the 3 or something, but that's how that works. And yeah, like I said, lab starts when lecture's over. We also, because we have a longer class with lab times included, we get a little 10-minute break in between lecture and lab. At least for today, I'll give us all the same break, but after today, so because I need to do stuff during the lab time. But after today, what I'll do is I'll just end the lecture, give you your assignment, and then let you take your break whenever you want because you're an adult after that. But today, we'll all have the same break so that I can keep us on the same page. There's a lot of stuff to do. So that's how that's going to work. What else? I think that's pretty much it. We're not an online class. So yeah, let me talk about expectations, right? It's a 4-unit class. We got to talk about what that means, right? So let's see. Do we know the rule about units? Like you take 4 units, what does that mean in terms of how much you're going to study outside the class? We know that rule?
8 hours.
Yeah, so you got to double it. So, okay, 4 units is supposed to mean we spend 4 hours together in class every week, though it's a little bit longer because labs don't count as much as lectures count. It's a weird set of math stuff that they do here, but it's supposed to be about 4 hours we spend in class, and then you're supposed to double that amount, and that's how many hours outside of class you're going to spend, you're expected to spend studying, doing your assignments, anything associated with the class, okay? So do expect to hit that rule several weeks in this class, all right? I've been told from many, many students that this is the hardest computer science class we offer here, all right? You made it. It's going to be a little tough, though. I want you to know what you're getting into. Okay, so there's a lot of new information. You guys know how to program now. It's going to be more about doing it well. All right, and there's a lot of nitty gritty that we'll have to deal with. Okay, so it's just a lot of concepts that are a little bit difficult. If you believe in weeder classes, this is the one for computer science. Okay, I don't believe in them. I believe that all of you can do well, but I just want to let you know what you're getting into. If you hate pointers, I'm so sorry. We are going to deal with so many pointers this class. It's going to be wonderful. And also, honestly, the concepts are a little bit more dry compared to Computer Science 40. 40 was great because I am programming. I'm making cool things. Things are working. My code is running. In 41, it's let's make that, but faster. It's not as exciting, I would say, but I think conceptually it is fun. All right, it depends on what you like. I like it. Hopefully that will pass on to you. You're going to write a whole lot more code than you did before. About 100 lines a week on average, let's say. You're going to have to think hard about those lines as well. And yeah, that's all that I wanted to say, I think. I don't want to scare you away. You all want to be here, I hope. I'll help you as much as possible. Caitlin will help you as much as possible. We're all here, right? And your peers will be here for you as well, okay? So take advantage of all that, and we will get through it together, okay? Just want to make sure you know what you're going to do, though. Yeah. So let's also talk about the technology loan program. We've got at our library a wonderful place where you can check out stuff. You can check out a laptop for the semester if you need one. Don't have a good one at home. If your internet is horrible at home, they'll also check out little hotspot routers for you. Take advantage of all that. It's wonderful. Okay. So if you need it, it's on a resources page on Canvas. I can help you fill out the form or whatever. So do take advantage of that. There's plenty to go around. And now we're ready for the syllabus. Yes? That's probably the most important slide for you. So here, the way to get to the syllabus is click there, but you have to go through the modules page. I'm forcing you to read all the things first. Hopefully you found that. Scroll, scroll, scroll. So eventually this will become unlocked. And you find it, and you download. Boop. This is us. Let me know if I have any typos, if it says fall 2024 anywhere. But yeah, let's scroll to the part you probably care the most about. We got to read the rest though. All right. So where was it? Grade breakdown. Right there. Let's talk about things. So, all right, we've got a textbook, and it's interactive and wonderful, and we'll talk about it in a second. I am going to force you to read that textbook and complete assignments during the reading, during the interaction. Hopefully you've seen it already. So I'm going to give you that pretty much every week. Those I'm calling homeworks. It's like reading assignments. 10% of your grade will come from those. The bulk of your grade is going to come from programming assignments, which I will call labs. You'll have a lot of those to do. That's the main chunk of this class. You'll do labs on our class server. I've given you all accounts. We'll get on that today, and you'll be turning those in. Okay, so that's the main bit of your grade. I also have the check-in surveys, which hopefully you found the first one on our modules page. How do I get back easily? Every week, this is how I take attendance for my online classes, by the way. Every week I give you a little check-in survey. The first week is just like introduce yourself. But after that, I'll start asking you questions like, I'm going to ask you to psychoanalyze yourself, essentially, so that I can like know what's going on. I'll ask you questions like, what are you struggling with right now? How do you think you could improve your current situation? What kind of resources can you identify? Stuff like that. So that helps me know like where things are going wrong for you. And then also it helps you figure out what to do as well. So, like writing things out, it really helps. And it's an easy 5% of your grade to do those every week. Boop. Yeah. And then we got tests. So we will have 2 midterms, sadly, in this class. Why are they called midterms? I don't know. Those will be 30% of your grade total, the 15% midterms. All right. I will try to have them a third of the way through the class and 2/3 of the way through the class. So we got an 18-week class. So week 6 and 12 is around when I want to have the midterms. All right, I'll tell you more about those later. We'll be taking them in class, and I'll force you to use the big computers, stuff like that. All right, and then we got a final. And that will be 20% of your grade, just another exam, a little bit longer. And we have a time for the final. Let's go to that right now, actually, while I'm thinking about it. So we are an in-person class, so we will all be taking our final in this room on, let me know if I read the table wrong, but I think our final is supposed to be on Tuesday, December 9th. Just like get it out of the way on the Tuesday of finals week at the same time as class starts. So 3 to 4:50. Let me know if I messed that up, but I think that's when it is. At least that's when I'll be here. And we get an hour and 50 minutes to take our final. It's a little bit shorter than a class time because it's just for the test only. Okay, that's when that's going to be. And then also, I like to give some extra credit. Where was I? There it is. So I also like to give extra credit. I'll give you some extra credit assignments throughout the semester, usually associated with an exam. And in addition to that, if you joined our Discord, you may have seen the ACM Club Discord invitation link, and you click that. The ACM Club is like our computer science club on campus, if you haven't heard of it, and they give some cool workshops throughout the semester. You can hear about those in the workshops channel on that Discord server, and I will give you half a percentage point of extra credit every time you go to one of those. All right, so go hang out with your peers. I think it will help. Sometimes there's even like technical workshops where you learn something as well, but I just think even the interaction will help. So it counts. I will cut you off at a letter grade's worth of extra credit, though. I'll give you more opportunities than 10%, but I will cut you off at 10%. Okay. Yeah, I think that's everything that I want to say. And this is likely the most important slide for many of us today. So are there any questions about it? Is it clear enough? All right. So, yeah, just read the rest of the syllabus. It's all on there somewhere. I'm pretty lenient when it comes to late stuff and some lowest scores. So here, I'll drop a few of your lowest scores. Read the syllabus to know which ones and the amount. But if something goes wrong one week and you miss an assignment, it will not kill you. It will be like it never happened. I want you to make it up, of course. I'll give you an opportunity to make it up for a little bit of credit, but I will drop a few of your lowest scores. And yeah, what else? there's that. And then also I want to talk about my due date policy. So this is maybe different to some of the other professors that you had, but I promise it's worth it for my class. Every assignment in this class, except for the check-in surveys, which will be due at, I think, 5:30 on Fridays, every other assignment is going to be due at 5 p.m. All right. So whenever you see an assignment and you see a due date, it means it's due at 5 p.m. It does not mean it's due at midnight for you. Okay. Keep that in mind. It's due at 5 p.m. for all of us. And the reason this happens, you've all taken 40, right? So that you know that this is like a technical class where technical issues arise, usually towards the end of the due date, right? Because that's when a lot of people turn stuff in. So I just want to be awake when stuff goes wrong. I'll even be having office hours a lot of the time right before due date. So I just want to be awake and able to help when things go wrong. And that's why I have my due dates at that time. Okay, so just remember, things are due at 5, not at some other time. Okay, though I do make some exceptions for certain students. So if any of these apply to you, just let me know. If you work at least half time, 20 hours or more per week, school does not count though. If you have 20 units, that's your fault, right? But some of us, we have to like work to survive. I will give you an extra 7 hours to do all of your assignments in this class. Then it really will be due at midnight for you, everything, okay? If you work at least full-time, 40 hours or more per week, or you do something that is the equivalent of a full-time job, like you care for a child, something like that, then I will give you an extra 15 hours on all your assignments. So now it's due at like 8 a.m. the next day for you. And that means you can either stay up late or wake up early, whatever fits your schedule, and get the assignment in. And we can all agree, right, that anybody who falls into these categories deserves that extra time. So let me know if any of those apply to you. Though keep in mind they're only for assignments, not for exams or anything. We're all going to take exams at the same time. Okay, that's my due date policy. Again, shout out if you have any questions about anything. I'm just going to try to go fast to keep us all awake. Also pretty lenient with late submissions, so I will accept quite a few different kinds of assignments late. All right, it's not, you won't get a 0 or anything. So I'll accept all these kinds of assignments late up until the last day of instruction. And what I mean by that is the Friday of the week before finals. All right, so not finals week Friday, but the last day that you could possibly have a class potentially. We won't have class, but that Friday, okay? Last day of instruction, I'll accept late stuff, but the second you turn something in late, I will cut off half of the percentage points, all right? So you're going to get a 50% penalty, but we know that 50% is better than 0, right? So like if you miss an assignment, like I might drop a few of them, but you should also complete it and get some credit anyway, okay? It's worth it. And you may have to remind me when you submit things. Actually, right now, they changed the way that Canvas works for instructors. It's disgusting. So I think you have to remind me if you turn anything in late. At least right now. But let's stick with just zyBooks assignments for now. All right. So at least tell me when you turn in a zyBooks assignment late. I think I'm good with check-in surveys actually. You turn in a textbook assignment late, that definitely doesn't get to me. So you got to tell me. It'll probably give you a 0 by default. So yeah, those are late submission stuff. Decently lenient there. And now are we ready to talk about the textbook? Hopefully we're all able to get it. So it's a wonderful, wonderful thing. Honestly, the book for 40 is better than the 41 book, but it's still good. Learn.zybooks.com. Oh man, I haven't logged in on this computer. It's a brand new laptop. Give me a second while I figure out what in the world my password is. I assume it's this. I gotta spell college right though. Give me 1 second to check my saved passwords on this computer. zyBooks. Aha. I will definitely be saving that. All right, so here's our book. All right, and I guess it looks like this for you by default. It's wonderful. It's got a bunch of cool assignments all configured already. Something has gone wrong apparently for some students. We'll figure that out later. But the way that you get it is you go to like the first assignment, like go to the chapter 1 assignment, and you click on it. So you actually get to the book. And then like if you have not bought the book, you click load chapter 1 in a new window. It's like their first assignment that I've assigned. And it will take you to a page where you can either enter in a key that you got from like the bookstore, or it'll like tell you to enter in your credit card. If you can do it with the credit card way and buy it straight from zyBooks, it's easier. I've heard horror stories that the bookstore sends you in the physical mail a slip of paper with the key on it, and that takes time. That's a little weird how they do that, but here's our book. It's great. It's got some cool stuff, and it like has interactive things. Like it's got little animations that will help you learn. I think it's really nice and useful and worth the money. All right. I wish it could be perfectly free, but like we gotta pay the people that made these pretty animations, I guess. So yeah, if you want to see all the assignments, they're out right now. You can go back to the table of contents of the book and go to the assignments tab and click on an assignment, like chapter 1 assignment, and you can see what I've asked you to do. So like these are all the things, and you can also see what your current score is on this assignments tab. All right, so that's how you check like what happened. Usually it should submit automatically to zyBooks, but somebody maybe bought the book in a weird way and not clicked the thing. I'll have to deal with that. All right. But yeah, that's how it's supposed to work, and it should automatically sync to zyBooks, but you can also, if you go to the assignments tab, you can also like, there should be like a submit to zyBooks link for you as well on this part if it doesn't automatically do it. All right, but that's how you go and get credit and see what I've asked you to do. Like here's chapters 2 stuff, and you can also see like how much you've done and the score you got so far. Okay, so that's how you see like what I'm asking you to do. Because this link doesn't take you, it takes you like to the first part of the thing, and there's like other sections that I want you to read. Okay, so I think that's what I wanted to say about the book. Yeah, it's wonderful. You can buy it from the bookstore, but probably if you can help it, probably try not to. But it should be the same to like return it if you drop a class or something. But check the fine print, definitely. But definitely don't go and buy it by going to the zyBooks website yourself. Go use that link in the first assignment so that it links to the Canvas properly. Okay, so yeah, if you have no life, all the assignments are up. You can get started. They're on the modules page. It should be at the bottom. Page up. Here they all are. And the order, and these are the due dates in theory that I want to keep for the semester, but it won't hurt you to get ahead. All right, so yeah, I think that's what I want to say about the book. Any questions about it? All right, so get started on that assignment. It's due soon-ish, I guess. Next, we have Discord. Have we all gotten onto our Discord for the class? Yeah, so it's a wonderful place as well. And this is where I want you to interact with your peers and with me. So if you can help it, do not send me a Canvas message. Do not send me a email, because I, as an instructor, have disgusting inboxes. All right, on Discord, I can easily see, oh, I have a message request, or if I already like have interacted with the person, it'll be on the left side for me. I can't miss it that way. All right, but yeah, this is how it works. So when you join our class server, you click here. There's an invitation link here. I guess I should probably make this bigger for you to see. So invitation link there, and then it will take you to this, and you'll only have access to the welcome channel and the guide channel. So scroll up to the tippy top of the welcome channel, click the 100 emoji to add the student role. That will unlock like announcements and general and random. And then you click the rabbit, because we care about making our programs fast in CSCI 41, and that will give you access to our CSCI 41 channel, which I'll talk about. Then you can also add your pronouns, and here's the ACM Club's Discord invitation link. So add that and go to they got a workshops channel where they talk about their workshops that they're gonna do this semester. All right, so that's that. And then yeah, CSCI 41 channel is where you'll interact with your peers. Right, everybody can see your messages. It's wonderful. And so when you can, send a message to everybody when you have a question. All right, so ask your questions publicly on our channel so that when it's 3 a.m. and I'm asleep, somebody who's also up can help you. All right, I do want you're all adults. I want you to use your judgment, though. I don't want you to give answers away in your questions that are public. All right, so don't like share 50 lines of code, maybe like 4 or 5 lines of code max. All right, just use your judgment. If you're going to give an answer away, don't. All right, if you think that's what's going to happen when you send a message. So try to keep that private. Send it just to me, or just to a tutor, or just something, or come to office hours, something like that. All right. So yeah, just use your judgment. Don't give away an answer, because that means everybody else can see it, and then nobody learned. Right. I want you to learn in this class. So if you have a question about a ton of code, there's no other way to ask it. Then you can send me a message. You can right click me, and there should be a message option. I cannot message myself. All right. So that's how that works. What else? Yeah, use Discord to contact me if you can. All right, I highly encourage it. So yeah, let me know if you have any questions about that. getting on it. It should be not horrible. All right, so that's our Discord. Next is office hours. So plenty of ways for you to get help. Come to office hours, stay after class. You can send messages on Discord, public or private. You can go to the tutorial center, so many things. Here is my office hours schedule, at least the plan for it. Come here and check it. This is when I want to have them at least. And lucky you, I'll be going to my office right after this class today. So every Tuesday is when I want to have my office hours, one of them at least, so all the green boxes. In addition to having office hours in my office on Monday, Tuesday, and Wednesday, they'll also always be on Zoom because I have one online class. And so you can click this Zoom link, either this one or this one, either one. They're taking the same place if you just want to go home after class and then talk to me virtually, whatever you want. All right, so you have that option. So that's my schedule. Just check it. I might get like meetings assigned to me. Don't know if why they would be after 5, but I might have to move things around. So just check it before you come. Yeah, so that's office hours. That's what I wanted to say about that. And then finally, the last logistics kind of slide is I just want to talk about getting help. So you've heard me speak about a bunch of different ways to get help. You got Discord, tutorial center, office hours, etc., etc. Get help when you need it. All right, that's what I want to tell you to do. So you're gonna get stuck. I want you to ask for help when you get stuck for too long. All right, don't just stare at your screen for 2 hours. That's what I did as an undergrad. It was not fun. All right, so I want you to learn from my mistakes. So let's set a time limit. All right, let's say that if you've been stuck for half an hour staring at your screen, you have not made any progress at all. 30 minutes. All right, 30-minute timer's up. Then you ask for help. All right, promise to do that, please. That's what I want. So then you ask a question, somehow come to office hours, go to the tutorial center, go on Discord, whatever you need to do, ask a question so that somebody, potentially me, can get you over whatever the problem is and on to the next one, okay? I'm getting paid for that, right? So yeah, please, please, please keep that in mind. Though, if you get stuck for 29 minutes and 59 seconds on something, that's expected, right? And that's when you have your flash of genius and it all works out. That's just how programming and learning in general works. But if you're stuck for too long, I really want you to get help. You're all going to collaborate in the future when you're working as a software developer anyway, right? So just get practice with that. Ask for help when you need it. I want you to do it. Okay? So I think that brings us to the end of all our logistics slides. Are we all still awake? Can we do it? Any questions? All right, so let me know if you have any. We'll figure it out together. But before we take attendance, I need to do that eventually. I would like to just give you a couple slides about what we're going to learn in this class. Like I told you that, oh, it's a little difficult. Like what are we doing? All right, so you've heard some of these words already. What we're going to learn in CSCI 41 is algorithm analysis and data structures. All right, probably heard those words before. We really care not just about making a program that produces the right answer anymore, because there are a million ways. You know that there's a million ways to do the exact same thing in C++ or any other programming language, right? But some of those ways are better than others. You probably realize that, yeah? We're going to quantify that, okay? We're going to talk very specifically about like which ones are better. We really care about speed and low memory usage in this class, all right? That's what we're going to learn about. And one of the ways to deal with all the complexity and like make things efficient is to write data structures or use pre-made data structures, which are just ways of structuring data and packaging it in the right way for the right use cases, all right? So that will help us, right? Because at the end of the day, like data structures are the backbone of any program that you write. Even if you're just making a bunch of int variables, those are still data structures, right? There's still little boxes in memory somewhere. And all your program does, right, is it takes input and spits out output. And it shuffles data around to get from input to output. That's all you're doing whenever you write any program ever. So we better learn about how to do it efficiently and how to shuffle the data with the right data structures, all right, to get that efficiency out of it. So yeah, that's our goal for the class. And before we get there, I have just like a few lectures on fancier C++ that you may have learned in CSCI 40, all right? So we're going to get up to speed on C++ in a way that's going to like enable us to learn about the rest of the cool stuff, learn how to make our own data structures and things like that. All right, so I've made a review video of all these things. So if you've forgotten anything about, especially pointers, go and watch that review video. It's an older video, but it still is applicable to the class. This is optional lecture 0. All right, so let me know if you have any questions about that. I'm going to assume you know all these things. All right, that's the goal. And yeah, I think we're ready. Any questions about that? Because that's pretty much the semester in a nutshell. That's what we're going to do. All right, so before we get to the actual lecture, I want to take attendance finally, and I will do that on our class website. So could you all please go there? It's www.lautensclass.com. You can get there also on the homepage of our Canvas. It's down here at the bottom, class website, but it's this one, lautensclass.com, and it will ask you to sign in. All right, if you haven't tried it yet, this is what it'll look like. It'll just give you a login link. And the way you log in is your username and your password right now are both set to your last name, all lowercase, no hyphens, no spaces, nothing like that, an underscore, and your student ID. So if this is your last name, this is your student ID, this becomes your username and your password for the class website, and also the class server if you try to get on that. And if this is your last name and this is your student ID, then this becomes your username and your password for the class website. It's lowercase, no hyphens, no accent marks, no spaces. Just get rid of all that. And this is what it looks like. So if you can get on, maybe change your password if you can get on quickly. But let me know if you're having any trouble with that. If you've already gotten on the class server, you know that has forced you to change your password. These accounts are not linked. So you have it's the same username and default password for the class website as well as the class server. But once you change one password, it doesn't change the other. Okay, they're separate accounts. So please, everybody get onto here and then get ready in the attendance app. It won't work until I start the attendance, but this is what we're going to do at the start of class from now on. All right, so I want us to all get in and let me know right now if you're having trouble. All right, because I have to drop you if you don't mark yourself here. All right, we still have to start the attendance, so a click won't work. Yes. And it sounds like we are not connected to the internet right now on this computer. You might want to set it in differently. Yeah, I don't know if this one's going to connect to the internet probably. You can try the Wi-Fi. It does have Wi-Fi.
Oh, yeah.
That's the internet's not there.
That's all my fault.
Set it like that.
Yeah.
Oh, great. A lot of us don't have internet on this big computer. Lovely.
This was not the problem last 2 classes ago.
We'll deal with it. We'll Which one do we use as a best?
Yes.
So maybe if you're stuck on login screen, then we have to use SC. Also, it's not working. Whatever, I'll mark you guys here manually if I have to. You guys have phones, you can go there on your phone, but
Yeah.
so yeah, take a couple minutes to try, and then I will legitimately come around and click buttons to mark each of you here that couldn't get on. Isn't the first week fun? I know the IT people are just running around going crazy right now. I will not start the attendance for a little while. I want to make sure all the details, like everybody on something, they can get on. I will start the attendance soon. Yeah, if you're able to get on, go and change that password. Some of these computers have Ethernet, some of them do not, apparently. Well, great. Looks like that one's unhappy as well. They're probably messing with it.
Is your laptop connected to internet?
Great question.
There's no hack.
It is not. It says it's connected to the thing, but it's not actually connected to it. Lovely. Okay. I think the entire internet's down then, huh?
The entire school our Wi-Fi.
Oh gosh.
Oh wow.
Well, I don't want to show all of your IDs to everybody. I don't know, man. What is the best way to do this? Yeah, that's fun. Hopefully they know about it. Here, let me call the IT people.
So far so good. So far, first day class is so good.
I need to figure out what the. You guys can watch me squirm. This is fun. Let's see. What is Clovis Community College Tech Support phone number?
I think it's
5294.
that now.
Is it back?
That's good.
Really? Tell me right now if it's not. You really? Okay.
It's working.
Okay, I just had to think about complaining. Okay, cool. Nice. Yeah, once you're in, you'll have stuff, and then eventually you go to take attendance. You click any button once I start it. Here, let me just start it now. That's fine. We'll just keep it running. But this is us. And begin. So you can mark yourself here. I don't care which button you click, whichever one you're feeling for the day. But yeah, if the internet now works.
So I say five very interesting answers.
Exactly.
I think.
Is it really? All right. Cool. All right. Is anybody now not able to go? I can understand. Okay.
That's what I thought.
It's exactly the same as
Yeah.
Anybody else not able to get on? Okay. You can click an attendance button right now.
I got attendance.
You did it that way? Okay, cool.
I was trying to figure out this textbook right now.
You having trouble? Same as username. You can copy and paste it. Password is your username right now, but yeah, go to take attendance for now. You can change your password after that. Click anybody. All right, a couple more minutes. I'll do so you guys can hang out. Just give us. All right, has anybody not said that they are here? That want to stop attendance. And if you did not say that you're here, you're going to get dropped. We're all here. We all clicked the button. Nobody's having any more issues. Yeah? Speak now. Or get dropped. And then if you are a very anxious person like I am, you can go right now to view my attendance to make sure you were just marked here. All right. So I'm good to stop this? Yes? Going once? Going twice? All right. Oh, see? Yeah. Any question? We're all sure, right? We're not going to get dropped? This is very important. The number just went up, guys. You got to tell me. All right, I'm stopping it. Okay. Cool. Yes, that's what we're going to do at the start of class from now on. Cool. That's wonderful. I think we're now ready to have an actual lecture. Yay. You ready? Let's do it. So I would like to just remind us what object-oriented programming is. Okay, and I'll show you some cool new stuff potentially. We'll figure it out. Stay on the class website though, because we're going to use it some more. All right. So first things first, I will be giving you a lot of information. A decent amount of this should be a review, but we have to kind of go fast at the start to get all of us on the same page, depending on where you took 40. I will kind of assume, hopefully, that you took it here, and that's how I'm building the lecture, all right? But one way to study all this stuff that I'm going to write today is to take the code, like I'm giving it to you, type it out yourself, try it, look at the slides, try to figure out what I did, and then compare with what I wrote, maybe. Something like that, okay? So yeah, that's what we're going to do. And before we get started with actual course content, I want to talk about the way that I run my lectures. So it's a discussion, we're talking to each other, and then sometimes I stop and I give you a question, all right? I ask you to answer stuff, sometimes on this ByClicker app that I've made on the class website, because that's where we're going to go next. So this is just a pun on the idea of the iClicker, so this little remote thing that maybe some of you have had to pay ridiculous amounts of money for to press A through E. So I've made that for us. We're going to use that in a second. All right. And then also sometimes when I give us a question to ponder, I'll let you guys get into groups, or I'll force you to get into groups. And that's called peer instruction, where you guys help each other and you decide on an answer. Every study everywhere has proven that you guys hate hearing me talk to you. You don't learn as well as you learn from having your peers teach you things. Okay, so it's worth it even if you're shy. And we're gonna have our first in-class exercise on the next slide. You can abbreviate that as ICE. And at Clovis, our mascot is the Crush, which I don't fully understand. And we're gonna call our in-class exercises, therefore, crushed ices. Hee. So what I'd like you to do, please, is go to the buy clicker page. I need to start the thing. On my end. Tell me, please, what is your major? I don't get to see it. They don't tell me these things. So let's understand the makeup of the class for our first few in-class exercise questions. All right. So please click the corresponding button and tell me what in the world is your major. Or did I not click it right? Oh, there it is. It is working. All right, I'll give you another few seconds. Like, is it computer science, computer engineering? Usually it's going to be A or B, but if you're in some other major, I want to know. It's interesting. Interesting to me, interesting to other people. All right, let me stop it and we'll take a look. Look at us, almost a decreasing graph. So a lot of us are computer science majors, which makes sense. 13 of us, I guess. Decent amount computer engineering, some other kinds of engineers as well. You guys got to know how to program for sure. We've got another STEM and also a non-STEM. That's great. So I'm all like, I appreciate the diversity, and like, you guys make the class better. All right. The fact that there's a bunch of different kinds of people in here. Yeah, so that's that one. Cool. I know a little bit more about you, and you guys know a little bit more about each other now. Next question, lightning round. So I am going to force you to use the Linux terminal in this class. Also, the Unix terminal is similar. If you have like a Mac, that's what that one's called. More or less the same exact thing. How familiar are you with the Linux terminal? All right, A through E, please. Real experts. I don't think I'd call myself an expert, honestly. It's way too much. Well, let's take a look. Nice. So, the unfortunate fact is we teach the terminal in CSCI 40 at Clovis. So those of you who picked A are going to have a tough time at the start of this class. All right, I just want to tell you that right now. I am here for you. I will help you. I'll give you resources. There are already some on Canvas, but I'm going to teach this class under the assumption that you have used the terminal before. Okay? So I will help you during like lab time and things to get up to speed, but you're gonna have to get up to speed quickly. All right? And so yeah, I expect most of us to be in B, so that's good. Some of us are very experienced, and I like to see that. So those of you who picked B, C, and D, please help the people who picked A. We'll get through it together. There's not a lot of stuff you need to do, at least today, but I'll give you like the quick intro to things. Okay? Cool. And then finally, the new thing for this class, CSCI 41, is all about data structures and creating them. Have you ever made your own data structures before?
Like independent from a class?
During a class, as an assignment even, that's fine. This one I expect most of us to be answering A. I will teach you data structures from scratch. But technically, sometimes in like a CSCI 40 class, some people teach like linked lists, stuff like that. Maybe you remember that word, that phrase. Yeah, tell me. Cool, yeah, so I expect most of us to be A. Some of us, B, cool. So yeah, again, those of you who picked B, help the people who picked A. We'll all get through this together, okay? So yeah, now we know a little bit more about the makeup of the class, and you guys know a bit more about your peers. That is exciting to me, and now we're ready. We're ready for actual information to be transmitted from my brain to yours. So yeah, let's do stuff. Are you ready? Let's make this happen. So, I guess I don't even need to make a code for this one because it's already on the thing. So I want to talk about all these things, all right? Just to make sure we're all on the same page, just in case you haven't seen them before, all right? So let's first talk about namespaces because we've all done the using namespace STD, right? Using namespace standard in C++. What in the world does that mean? A namespace is just a place where you can put names. Names of functions, names of variables, stuff like that. It helps you keep things with the same name separate. So that's the reason all the standard library stuff is in the standard namespace, because then you can make your own version of cout. You can make your own PAL function or whatever, and it won't clash at that point as long as you don't say using namespace standard. You gotta like qualify it at that point. So like, here's how you can make your own namespace. Be like namespace foo, namespace bar, and then you can put stuff inside of it. All right, so you can put two functions with the same name, and there's no clash, because normally if you didn't have the namespace stuff, it wouldn't compile. It's like you have redefined f. I don't know what you're talking about, dude. So this is useful, all right? And the way you get at the stuff that you've put inside of a namespace is you say the name of it and then 2 colons. Have we ever, like maybe somebody taught you, like before you use namespace standard, you could have done it this way, standard colon colon, right? So that's a thing. Cool. And so now you have access to this one with, got to qualify it, foo's f. You can read the colon colon as like an apostrophe s, all right? So yeah, now let me start writing stuff. So a namespace, important word, keeps separate things separate. So we've done the using namespace standard. A whole lot. And what that means is like in the standard library, all the code that you've been using and importing is like somebody said namespace standard, and that's where they put all the code. That's what you've been including this whole time, all right? That's kind of neat. Yeah, so now you know how to get to foo's f this way, bar's f this way, and so I kind of want you to think of that colon colon as an apostrophe s. It's foo's f, it's bar's f, it's the standard libraries, cout, stuff like that, all right? So yeah, if you want to write your own cout, you can now. Just don't use namespace standard. You can still get at the old one by saying standard colon colon cout. Yeah, that's the beauty of it all. So yeah, you can say using namespace foo if you made your own namespace called foo. That's what that means. Just like give me everything so I don't have to qualify it anymore. Does that make sense? Interesting. So now, yeah, it's like standard libraries, please, cout. That's what it will give to you. All right, so that's namespaces. I don't think I need to give you slides for that. But for my next trick, I want to talk about making programs with multiple files. So again, this is something that I taught in my CSCI 40 class, something that in theory you should know, but I want to just like make sure we're all on the same page. All right, so there's a concept of implementation files and header files. Okay, and so I'm going to make just a simple example to show that to you. Because like you're not going to make your programs for when you're working at a big company in one giant file, right? You want to separate logically different things in different files. And so we like to, in C++ at least, separate our stuff into implementation files where you got code. Those are your .cpp files. Other people like to use like .cc, .cxx, because this is supposed to be like .c++, but plus signs are not allowed in file names, so it's like a sideways plus. That's why they did that. But we're going to use .cpp in this class. That's where you put the actual code, like the bodies of your functions, of your methods. And then you've got header files. That's where you just say what is going to be implemented in the implementation file. So header files start with, or they end with .h, .hpp, .hh, again, .hxx, like a sideways plus, h++ kind of. And those contain declarations of things that you promised to implement and make part of your library. Okay, so that's what's going to happen in those. And that's what a header file contains. Just declarations, just like the name of the thing, semicolon. All right, you will implement it in the implementation file. And that's how you make libraries. All right, so what I'm going to do is we also need to talk about header file guards, which I'll get into in a second. But I'm going to make a cute little library that contains one function. All right, I'll make a little library that has an add one function in it. So I'm going to have in my little library, these two files will make up my add one library. And the header file will have the declaration of my add one function, the one thing I want in the library. The add1.cpp file will have the implementation of that one function. That's where you put that. And then main.cpp will be just some other function that's not part of the library, or some other code, not part of the library, that will hold the main function, like includes the library, uses the function. All right, so that's what's going to happen. So let me make that for you right now. So I'll make 3 files, and I guess I'll make them in like a folder. I'll make it called add one library. So you can all go look in all those things when I give you in this one folder for all the stuff that I do right now. When I give you this code. So all right, I've got an empty folder called add one library. I'm going to make a file called, let's start with the header file, add1.h. What I'm going to put in that file is the declarations of all the things I want in this library. All right, so I just want one thing. So declarations go in the header file. Is that big enough? So declarations of things. So I just want one thing in this library. I'll call it add1. It takes one X and it adds 1 to it. That's its job. It's a very simple, silly function, but that's the point. So that's my one file. All right, so I got it there. And now let me implement it. Let me make a new file called add1.cpp that takes the thing I promised to make in my header file and it actually makes the thing. All right, so it gives it a body. So I'll make a new file called add1.cpp. So give that a body. And how do you add 1 to something? You say return x plus 1. All right, so implementations go in the implementation file. So that's where you put bodies of things. And it is customary to include your header file in the implementation file. For this one, we don't have to, but when you make any class, for example, like you got to do it this way. So it's just a good habit to get into. Always include your header file in the implementation file so that it knows about all the stuff you've decided to make here. And so I've got 2 files so far. I've got add1.h and add1.cpp. Got the declaration of the thing I'm putting in this library and the actual implementation of it. Is that coming back to us? Does that make enough sense? So I got 2 files so far. Now I got to make the third. This is going to be the one that uses the library. Okay. Well, let's do it. So give me a thing. So I'll make a new file called main.cpp, and this will have the main function. It will include my add1.h. You include the header file. All right, the header file gets kind of copied and pasted into here when you say include, and that gives me access to that function that's part of the library. So now I can use anything that's declared in this header file, which is that add1 function. All right, so now I can use the add1 function. Beautiful. That's what I wanted this whole time. So let's be like, hey, user, enter a number. Colon space. Give me that number. And you can use our beautiful function called add1 on that number. Okay? So that is more or less the setup. You got all these 3 files working together. You got the main function file that it's not part of the library. It uses the library, includes it. You include header files only. The header file has declarations of all the things in your library, no implementations, just whatever a user needs in order to use the library. They don't need to know about the details. And then here's your implementation file where you give the bodies of all of those things you promised to make in the header file. Okay, so these 2 on the right are the library. Does that make enough sense? Are there any questions about that? And they're all going to work together. So we're going to compile this and run it, and it will be beautiful. We'll make one program out of the deal. The last thing I want to say, just briefly, I'll usually give you your header files in this class, but there's a way to it's not going to be this easy, but there are subtle ways to do the following. In add1.h, there's weird ways that you could end up with this kind of thing happening. Add1.h, include yourself. And that would give an infinite loop of inclusion, and that would break the compiler. All right? So to get around this, you include what are called header file guards. There's an easier way to do this. I'll show you the harder way. It looks like this. Oops. Not come once. This stuff. In case you've seen it before. If you used Zybooks in your CSCI 40, it should have shown you this. But what this does is it makes a compiler level variable that's usually something about the same name of this file. And it's it makes a little if statement. If I've never seen this variable before, then make it, declare it. That's your ending if brace. And so you put the file within that. And then if it ever sees it again, it's oh, this thing's already defined. I don't need to define it again. So it won't infinitely include it. And so that gets you around that problem. I don't really want to spend too much time thinking about that, but that's a potential issue, and that prevents that issue. Okay, those are called header file guards that keep you from infinitely including yourself. Okay, so with that, we are ready to compile and run. So here we've got the main function file, we've got the header file, we've got the implementation file, all working together. And so I'd like to compile this program together, right, as one big program. The This is the main function. It's going to use the library stuff. The way that we do that is we give them to our compiler, which in this class we're going to use the GNU C++ compiler called G++. That's the terminal command for it. Okay, so here's how you do it. We got all these files working together. We've got add1.cpp, we've got add1.h, and then we've got main.cpp right now. They're all working together. And let's see. What we're going to do to the compiler is you only give the implementation files. So you don't have to give the header file because that's getting like copied and pasted whenever you include it. Like it's getting copied and pasted in these files anyway. So you kind of leave the header file alone, and you kind of want to give this to main and have them interact. That's what we're going to do. All right. So we're going to give only the implementation files to G++, and then we say -o what we want it to be called when the output has been produced. Okay. Yeah. And so, like I said, whenever you include a file, even in IOStream, what it's doing is it's essentially copying and pasting this entire header file to be right here. And that's why you don't ever need to include that whenever you give that, give your files to the compiler. Like it already got it, because like what happened was when I included this, it really legitimately did this. Boop. That's what the compiler sees. That's what it means to include something. It copies and pastes it. So, all right, the moral of this story is here are all my files that I just made. I would like to compile them. I'm going to say G++, please take the add1.cpp file, take the main.cpp file. I don't need to give it the header file because that's going to get copied and pasted automatically. That's just what inclusion does. And I'd like you to call the final thing, the executable file that you create for me, if this actually compiles, let's call it main. So -o main, hit enter. Now I'll create a new file called main, and that's my runnable thing. All right? And I can run it. That's my program. /main to run it. Enter number 42 creates 43, and keep on rerunning it, 55, 56. Okay, so that's our first example code of the class. Yay! Are there any questions about it? See how they're working together? All right, so yeah, just shout out if you have any questions about anything. But that's our first example. Now let's get close to object-oriented programming. So let's talk about structs, which is like the thing before object-oriented programming. Technically, a struct makes a data structure, if you've used those before. So here's my silly example. All right, here's going to be my silly running example. It's a classic example from an old C++ textbook. That's why I use it. I'm excited. So all right, I'm back in the original lecture 1 folder. I'm going to make a new program to motivate structs in classes. All right, so here's the silly program I would like to write right now. Let's make a program that keeps track of the following information as a user gives me more and more things. Like they're going to type numbers and hit enter, and I'm going to keep track of those numbers, certain features of those numbers, certain statistics. All right, so I'd like to take these two variables, count and current max, and use those. All right, I want the user to give me a bunch of numbers, and I want the program to stop once the user gives me -1, like that signals they're done. And so I would like to keep track of how many numbers the user has given me so far before they're done. And also the maximum of all the numbers. We'll keep track of whatever the current maximum is right now. And towards the end of the program, of course, it will be the final maximum of all the numbers that I was given. Okay. Maybe this is a program, like this is an embedded software that is like running on somebody's pacemaker. Like that's what you're going to keep track of, right? If you're in the health sciences or something. So like you're getting heart rates. That could be how this program is used in the real world. Like we want to know, all right, how many times did it beat? What was the largest, whatever it's called, pressure or whatever that was given off by the heart? I'm not a biologist, but let's make that program, right? So I'll call it pacemaker.cpp. Like imagine that's what it's part of. So here we've got count. We've seen nothing at the start, right? So let's start that at 0, and then current max. I guess technically I could set that at like -infinity if I wanted to, whatever that is for ints, but I'll just set it to nothing right now and hope for the best. We'll deal with it. And then I want to get potentially infinite numbers from this user until the battery goes out or something. I don't know. So I'm going to make an infinite loop. So while true, forever until the end of time, until the user types -1, I would like to get a number. So enter please user the next number, or -1 to quit, and give me that number. I forgot a semicolon. Give me that number. Let's put it in a variable real quick. And then using this number, either they gave us -1 and they're done now. So if it was -1, then we'll break out. Otherwise, if we're still in here, that means we got a good number and we want to update our count and our current max. Yeah, that's what I want. So, all right, if we got a valid number, then it should be just count plus plus, right? That's another number that I cared about counting and keeping track of. And now we have to keep track of current max. And current max is undefined at the very start. So if we just got our first number, that is the one and only number, that is also the max, yes? That's a special case we better keep track of. So if count was just 1 right now, we just made count 1, that was our first number, then current max is that number. Like there's no ifs, ands, or buts about it. Like that was the first number. That is our only number, therefore it is the max. Otherwise, the only other way that I want to update the max is if that new number that wasn't the first number happens to be bigger than my old guess of the current max, yes? So otherwise, if n, this new number that I got called n, is bigger than my current max that is now set, I know it's been set properly, if it's bigger than my current guess of the max, then it is a better max. Current max should be that as well, should be n again, but it's not the first number, it's just like we just saw a bigger number. Whee! So yeah, that's pretty much the loop. Once it's done, like we can print out our count, like we got -1, so we can print out our count and we can print out our current max, and they should be accurate, yes? Are there any questions about this program? Does it make sense to you? What it's doing? Like this is like CSCI 40 simple stuff, but we maybe have taken a summer and not looked at C++. So I just want to make sure we can read this and understand it. And that is paramount. And now let me compile it. So it's just one CPP file. I'll call it pacemaker by itself without an extension. So that compiled, let's run it, and I'll give it some numbers. I don't know, 1, 2, 3, 42, 4, 5, -1. So apparently I gave it 6 numbers and the biggest was 42. Cool, it worked out. Okay, yeah, so that's how it's running. It seems to be working, and pretend that's in somebody's heart and keeping track of important data about the heartbeat so that it knows when to like do the shock thing. Yeah, so that's our first program. We good with that? We're ready to make it better? All right. So let's criticize this program now. We've made these variables and they're just out in the open. Count and current max. Wouldn't it be nice, like if that's the data we're keeping track of, wouldn't it be nice if we packaged it together? I think so. So let's use a struct. A struct is a C++ thing that you can use to make a new type that will let you package things together. All right. So sometimes people call it a plain old data structure or a pod. I'll just call it a struct. And what a struct can do is it can hold a bunch of different values of different types, and they'll have names. It's just stuff inside of things. So I'm going to make like a struct called, what should I call it? Like statistics or something. I'll call it like stats. So I'm keeping track of a bunch of stats. And making a struct gives you a new type to use. Like I'll make stats s, make a variable of that brand new type. And what is inside of s now is other mini little variables. Like this is what I want to put in every stats struct object. So I like a count, that will be an int. Like it'll have that. Every struct will have that. I want a current max. That'll be there. So it's types within types. And then let's also, just for fun, keep track of all the numbers that we were given. So I'll use a vector. Call it nums. Push back to it each time. Whee! So it'll look like that eventually. That's what I want. Let's do that. So instead of this, let's copy and paste so you can see the logical progression of things. I'll make a new file called pacemaker structs.cpp. Paste all this in. And so instead of doing this, let's make a struct. Struct, I'll call it stats. That's the name of the type I want to make here. And then every stats object, everything of that struct's type, will have these 3 things inside of it. I'll have a count, a current max, and then also the numbers themselves as a vector, so I better include the vector library. Okay, so they're all there. And so now instead of all these, I can make just one stats object, stats s. And now I suddenly have inside of that s a count, a current max, a nums. Yes? Does that make sense? So if you never saw structs, if somebody went straight to classes in your CSCI 40 class, it's just all a struct is it's just a class with nothing but member variables. Okay? That's all it is. It's like a more primitive thing. It came before classes were invented. So I'm working my way to classes right now. So all right, I need to initialize, just by default, current max is created, it's uninitialized inside of s, but the count inside of s, that we need to give something. So s.count, use the dot, equals 0. All right, So now essentially I've done the same thing. And now what do I want to do? So I've got, if it's -1, I'm done. I don't want to do any more. But if it wasn't -1, this was a valid number, I better add it to the numbers that I'm keeping track of, right? I can be like, S dot has some nums inside of it, right? That's what that vector is called. S dot nums, this is a valid thing I care about, nums dot pushback. That end that I just saw. So add it to the vector, increment the count, but the count is not just a variable out in the open, it's part of S now. Right? It's part of that type. Here, let me put the type declaration over here so you can see it. That's what a stats thing is. That's what we get inside of our S object. Right? You still call it object when you make something of a struct. So it's s.count plus plus. Oh gosh, what have I done? That's the s.count plus plus. If s.count is equal to 1, s.currentMax. The current max is also inside of S. Otherwise, if n is greater than s.currentMax, set that. Stuff like that. All right, and then finally it's cout s.count, s.currentMax. And for fun, we can print out the vector as well. All right, so like go through the vector. So for every num inside of S's vector called nums, give me that thing and print that number, and we'll just space separate them. How about that? With a new line at the end, because we want it to be pretty. Okay, so this is the new program. So it's hard to show it all to you, but we're making this, and now our S holds a count, current max, and nums, and I'm going inside of that s.nums, getting the nums of that S object, getting the count of that S object, mess with it. Does that make sense? Questions about that? That's what I'm doing, and then I'm going inside of that again, just like to print out everything at the end. So that's more or less the answer there. So I'm making that S object up there. Let me show you, I guess, the loop. Why not? So to compile this, G++, name of the program, pacemaker structs.cvp -o, what I want it to be called. Well, let's call it pacemaker structs like that. If you forget to give a -o, it will call the default name of your program a.out for historical reasons. But we like it to be a pretty name, so I'll call it usually the name of the program without any extension. So there it is. It compiled. It's in my directory now. Pacemaker struct. So what did I do? 1, 2, 3, 42, 4, 5, -1. So still got 6 numbers. The biggest was 42. And then here were the numbers. We kept track of those too. And it's happy. So does running it make sense? Like, do we see why we produce that particular output for that particular input? And of course, if you run it with something else, it'll be different. Okay. We're almost there. There's a lot to do today. So, okay, it's gonna be a longer lecture. So, okay, now let's motivate classes, like classes and member functions. I'll also teach you something called friends, which you probably don't know. Wouldn't it be nice again, right? To be able to ask my stats object, like S, hey, you know what? I got a new number. Just like, if you could talk to it, right? We're all lonely as computer scientists. Like, I want to be able to talk to this S object and tell it, like, hey, I got a new number, increment your count. Hey, I got a new number, put it in your nums vector. Instead of me having to go in and tell it what to do exactly, it's like, let's make methods with names and things to be able to ask it and poke it and say, like, I got a new number, deal with that new number. Something like that. So all of the logic can be transferred into the stats object itself. It can think for itself. It is an object. It's a thing that you can interact with. It'd be nice to have some operations associated with the struct. All right. We will use a class, right, to give ourselves methods, and we will call ours. This is the example from the old textbook. The class will be called the statistician because it's like a thinking thing, right? So like a real life person that we're giving numbers to, and it's thinking about those numbers. So that's going to be the name of our class. Not just stats, it'll be the statistician, all right? And here are the operations I want it to do, like add any number to yourself, inside of yourself. Give me the max that you've computed so far, or even give me the average that you've computed so far. Do some stats, right? So we'll also need a init, and I'll talk about why in a second, just to initialize our object. But do you see how, like, if I tell my statistician object now, add a number into yourself, like the user just typed 1, give it 1, it can keep track of dealing with the count. It can keep track of pushing back to the end of the vector. Like it can, all that stuff is now moved to there, which saves us thought as the user of the library, as the user of this class. Yes? That's what it's all about. Save ourselves some thinking and make our code smaller. All right. So yeah, the statistician is a new type. Is what we're gonna make. Statistician. And it's going to be, it's going to have, in addition to what it already had, like we're going to keep that stats struct along for the ride. It's going to have still data associated with it inside of every statistician object. It's going to have some data. It's going to have like, what's my nums vector? What's my current count? Which I guess you can get out of the vector, but that's beside the point. And then now, in addition to that, it has some operations that you can ask it to do for you. Be like, all right, add me a new number into yourself. Add num. Go and give me the average, blah, blah, blah. So that's what we can do. That's the difference between structs and classes. In addition to data, we now have operations. All right. So let me implement these things in a public way. We'll deal with access control in a second. But here's the idea. All right. So again, I'm going to steal all this. Pacemaker classes CDP. And so instead of this, I'm going to say class stats. Do I want to implement it inside of the class? No, I'm implementing it outside of the class. Here are my data. I'm just make everything public. All right, that's what I'm going to do for the start. So this is my data. Data, and then I'm also going to have some operations associated with it. Question. Oh, this was for the struct. Eventually, for the class, we can use a constructor, right? That's the goal. But for a struct, it's just whenever you declare a struct, it makes all this memory associated with it. Like S gets a count variable inside of it, a current max, and a nums. But we said nothing about what to do with those in here. Like you could have kind of initialized it like this, but essentially it just made like 3 variables. And I guess the vector got initialized to emptiness. But these two are just like normal ints living inside of here that are just as holding just as much garbage as they would have if we put them in me. Does that make sense? Yeah, that's what happened. They were uninitialized because we didn't say what to do. They were just declared but not initialized. Yeah, good question. Other questions? So we can fix that eventually. But let's start with this. So we got our data, and then in addition to that, I'll put it on top for fun. We got our operations. So we're gonna need an init operation just to initialize everything. We'll deal with that for a second. Void init. And then we want add number, get max, and average. I'm going to type like the wind. So add number, get max, average. What is add number going to be? It's just void because it just like does something, but it takes the number that I want to add into it. Get max that's going to give me back the current max as an int if I'm taking ints. And then average is the average of ints can be a double, right? So that better return a double, but it takes nothing. Okay, so let's do those. And I think that's enough for now. Let me implement them if there aren't any questions. Does that setup make sense? That's how we're going to interact with it. And so the way you implement stuff outside of a class is, oh, sorry, I need to call this statistician, right? It's like a thinking thing. It's like a real life object, real life person. We're talking to it. Statistician. And this is now, it's not just a function, because it looks like a function if you put it out here. It's statistician's init method. That's how you say it. So it's given itself as a little namespace. Let's see. Statistician's add number method. Statistician's get max method. That's how you qualify that and say like, no, C++, I'm not just writing a function right now. I'm implementing a class outside of the class itself. So all right, what do we got to do here? Oops. Let me just give it some empty bodies real quick. All right, so again, I can split screen this. Here's the declaration of the class, and we're implementing it down here. All right, so what do we want to do in init? Just for fun, I mean, we could have said this, like my count member variable, set it to 0, but for fun, what I'm going to do is just like, let's initialize the numbers. Let's say that we already got a number, like the default initial number is 42. It's always going to be 42 inside of here. All right, just to have something other than 0-ness to do here. So when I initialize my statistician object, I would like to set not the count to 0, but to 1, because I want to put these nums in it. I want to have just a vector holding 42. That will be my nums vector. My count is going to be therefore 1. There's one thing, and my current max is whatever that is. So current max is equal to the one thing that's there, that's the 42. So I'm initializing my statistician to hold one number, which is 42, and setting everything appropriately. Okay, that's what's happening. And That's more or less what I want. Now, all right, what does it mean to add a number into my statistician? What do I want to do? I've got all these member variables. I got count, current, max, and nums. How do they need to be updated when I add a new number? That's now the question. Well, I guess we got another num, so like add that, nums.pushback, that n, like all the stuff kind of that we were doing down here, we're kind of dealing with in a different place now, which is nice. And I'll show you how we can delete that stuff now. So add a new number, pushback n, we added a number, so count plus plus, and then we've got to deal with the current max, right? And so I can copy and paste a lot of this. Like, it's essentially all of this. I just put up into here. So I already did the first 2 lines. I converted them properly. That were those. And then these, essentially, now we're just messing with our own member variables. If my own count inside of me is 1, deal with it. I guess it'll never be just 1 anymore because of the way we're initializing things. But I don't know. For sanity's sake, we can keep it there. But that's what it means to add a number, right? That's how it's thinking about itself and its own stuff. Cool. Does that make enough sense? That's what add number should do. Get max, very simple, right? We've got the current max member variable. You're asking the statistician, hey, you're poking it, saying, hey, please give me that maximum that you got inside of you as an int. So you just return your current max member variable. Then it's happy. And then average, that's the last one, right? What do we got to do for average? Well, we have our nums. We got to go through them all, right? Add them all up, divide by the size or count. So double, it's got to be a double because potentially the average is going to have decimals in it. All right, so average starts at 0. We're going to add every number in for every int n in nums. Just add that into average plus equal to n. And this is something I purposefully never showed my CSCI 40 class. Maybe you read about it in a book if you took it from me, or you saw it from another professor if you took it from another professor. But if you have just a single thing inside of a body somewhere, you do not need curly braces. So the cool kid's way of writing this loop is like this. That one thing in the body, just like put it on the same line. You could have indented it if you want, but there's only one thing on that line. You don't need curly braces for that. All right. And then finally, average equals average over count. And this is going to actually do double division properly because average is a double. So that's perfect. So it's not going to do weird integer division and chop off decimals. It'll work. And that, I think, is that. Let's give it a, like, let's have it run now. So again, stats s, no, it's statistician. Statistician s, how about that? And then, hey, s, initialize yourself. Should always do that at the start of everything. And then, what else? Dun, dun, dun. What else should we do? Then we have to get our numbers, right? We're still getting a bunch of numbers from the user. And then we're interacting with our objects. So like, all right, if I just got a valid number, see what the loop is now going to become. It's just like, all right, s dot add number n. That's it. This may be cleaner if you want to put this in an else or something. I don't know. Whatever you like. And again, these didn't need to have curly braces. You can deal with that yourself if you'd like. But like, this is now our while loop, and it used to be this. Boop, 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 boop. Of course, it's not going to do it right. But like, this was super long. We were dealing with all the stat stuff. Now it's all packaged together. Like everything's happening at a number. Isn't that great? We're doing that. And then all this stuff down here, now it's going to be like cout s dot count. That can still work. Count. Now it's like, we should probably be using get max for this one. Done. We'll still go through the nums. Should still be happy. So G++ pacemaker classes. -o pacemaker classes. I think that's good enough. So 42 is already in there. 1, 2, 3, 43, 4, 5. So there's really 7 numbers now. The 42 was always at the start, but it seems to be doing things correctly still. All right. So it's all working together. We got all these methods doing their things. They look like this. Add number, get max, and there's average. So here's those two. Here's these two. Okay. They all make sense to us. All right. If they do, I have got a question for y'all. Go back to that by clicker page, please. You know morally what all these methods do. I don't know if I'll be able to show them to you at the same time, but like you know what it took to implement init, add number, get max and average, like a loop through, right? Stuff like that. It's got an if statement, stuff like that. So remember how they're implemented. And here's my question for you, right? First of all, I'm going to split you up into groups. So what I want you to do after I give you the instructions, I'd like you guys to get into little groups with people, please. So say hello to the people next to you. That will be your peer instruction group for the day. Take like a minute to introduce yourself, say hi to each other, talk about your summers. And then after you've introduced yourself, please answer this question on the ByClicker page. So I'd like to take the methods that we just wrote and order them from fastest that are going to run on, let's pretend on my laptop, the fastest one that's going to run on my laptop to the slowest. I'd like to order them in that speed, like using speed as the qualifier there. So which ordering do you think is the right order? Okay, that's my question to you. And I don't know if I can show you all this very easily. I'll do my best. Here's the implementations. I'm just going to make it really small if you want to come up here and look at it. Bring your binoculars if you need to. But say hi to each other and talk about that question, please. I'll give you some time. Oh, absolutely. Yeah, whatever you need to do. Yeah. And then let's see, what was I gonna say? I'll give you guys 5 minutes. All right, how about that? And I'll be here if you have any questions about the question. It's going to be your life as a CSCI 41 student. Very good.
I think it depends because like it depends how you structure it. Like what functions you write first, and then when those functions are called. I think it's just the numbers. Well, so that's top to the bottom, but like if you just write those like and then you have like a function that calls those. I think it especially, or if you're doing it in a header file. Yeah, it's not like because like it goes top down. So I don't think because I think we're doing it in your buffer, right? It doesn't really matter, but it depends on order. When you're writing the function out in a file, not much. But when you call it a different file, I guess it could be something else. I'm probably off, but yeah, never about folders. So I forgot.
All right, one more minute, then we'll come back. Get your best guess in by then.
And it basically goes down to.
I didn't need to do that.
Yeah. Okay.
I love these things. Perfect timing. All right, let's come back. Let's take a look at what we're thinking. Give you 5 seconds to click something if you haven't clicked something yet. Let's see what we think. If we agree, if we disagree, I don't know. We'll figure it out. Yeah. We're all over the place. Which makes sense. I mean, I haven't taught you how to do this yet, right? But I just want to see what your intuition is thinking. It looks like most of us think C, like not a majority, but like the largest number of us think C, and then it's kind of like a split between A and A. We definitely don't, most of us don't think it's B. Some of us, one of us thinks I'm tricking you. Let's see. Let's figure this out together. All right. What do we got? I'm going to copy this to the next slide. Well, we want to order these relative to one another. All right. So what's going on in all these things? All right. So like init, think about it. It's all right. We got 3 lines. It's just running things. It's setting up a vector. It's like it's shuffling memory around. It's always the same memory every time I run it. Right. It's always putting 42 in a vector. It's always putting 1 in a count. It's always putting 42 in a grid. It's 3 lines of code. 3 lines. Not too bad. I don't know. We'll get back to that. Add number. There's more lines, right? So maybe it's a little worse than init. It's got a few lines. And then it's got some conditionals, and sometimes like it's messing with one thing. It's checking stuff, right? Potentially it has like 2 checks that it goes through. Conditionals. So maybe a little bit worse than init, I would say. Then get max, definitely we know that one's the fastest, right? No matter what, get max, totally the fastest. 1 line, just immediately returning something. Can't do any better than that. And then an average is hard to place, right? Because it's got a loop. And what a loop does is it repeats lines of code, right? And the condition as well. But we don't know how many times it's going to do that repetition, do we? It depends on how many things are in nums, doesn't it? So if there's more things in nums, average is slower. Does that make sense to us? So it depends. Depends on the length of the vec. If the vector is empty, or has that one thing in it from init, this entire loop goes away. And now suddenly average is faster than add number. Does that kind of make sense to you? So like relatively. But if nums has 100 things in it, now it's the bottleneck. Now every time I run it, it's going to take, like it's essentially running 100 lines of code because it's repeating that body. Does that make sense? So the answer is I did trick you. It is E. It does depend. Do we see why?
Yeah.
If you're the one person, nice. Awesome. So that's kind of why, if that makes sense to you, right? A lot of us thought it was maybe this one. And so maybe usually it's going to be this one or something. Or sorry, maybe like get max, then init. Maybe like usually it'll be C or something. But it's going to depend, all right? Also depends on the like CPU architecture that you're using, how the compiler actually compiles the thing. There's many more details to get into that will take future CSCI classes to deal with, but this is a good enough stopping point for now. Does that make sense? Everything we just talked about. So yeah, that's what we're going to learn, all right? So let's make the class correct now, because like I said, everything was public and that's disgusting. So let's fix this, all right? What I can do right now is a little unfortunate, all right? Our current class has an issue because I can do the following, all right? I can be like, hey, statistician S, you know what? S.count, whatever you thought it was, it is 100 now. I'm allowed to do that. I should be arrested, right? That goes against everything. That ruins average now, doesn't it? right? Because average was dividing by the count. Like that is horrible. I don't want that ability. I should not give myself that ability. What I can do to fix it is to introduce private things. Every member variable of yours should always be private. And hopefully you've learned that rule by now. That's the first step, okay? We do not want to be able to modify any of our member variables outside of our member functions. The member functions know what's going on because they're part of the class. Anybody else, no. I don't want to have them deal with that. It's not right, okay? So I guess I should also run average here. So see how s.average. But I don't want this to happen, and so what I'll do is I'll say this data is private. It's only accessible to the implementers of the class, all right? And that's the way to do it, all right? Everything else, all the operations you give to the user like this, they are public, and now a lot of things fail, all right? Now this line will not compile. It's like, oh, this count is private. You cannot do this, which is exactly what I wanted, yes? Beautiful. So that also kind of ruins these. GetMax is fine because it's a method, but like if I want to look at the count, I just want to look at it, I want to mess with it. Now suddenly I need a method for that, right? Because I've limited access. So we, the implementers of the class, know what's best for us. We're going to give access to the user through public stuff only. Okay, so we've got a get count we can now give. We can say get nums as well. And it's not just an int, it's giving back a vector. So if we want to look at something, that's fine. We'll give access to this through getter functions, they're called, or accessors. So those are new things. And that will fix this issue that is glaring. Nobody's going to get arrested anymore. So what does get count do? It just returns whatever the count is. So this is, it won't let me touch it now. It'll let me just look at it. That's the whole point. Return a copy of nums. And now I can use these guys down here. So instead of, I got these now. Instead of s.count, it's s.get the count for me, please. Get max, s.get nums. I guess that works like that. And everything else is still happy and all right. And now it should compile, in theory. Go away. 1, 2, 3, negative. Yeah, and the average was apparently a whole number. Let's do that again. So just for sanity's sake. 1, 2, 3, 4, 5, 4. Cool, now we got a decimal place, so that's working too. All right, so now that's how it's looking. Questions about the new state of our class? All right, sorry there's just so much to throw at you guys today. It's going to be one of the longest lectures just to get it all out. I apologize. We'll get through it though. The next thing, and I guess mostly, just two things. This one and one more thing. Let's now talk about how we can give certain people access to our private member variables on a case-by-case basis, right? Let's make a function that's called add 1 to every number outside of the class, all right? The goal of add 1 to every number is it takes a statistician object and it goes through every number in that statistician object and it adds 1 to it, all right? It's not horrible, but that's the goal of it. So it takes a statistician and it messes with it. So it's going to take it by reference. It's going to mess with it. It'll be a void function. This is a function. It's not a method. It's outside the class, but it will take an object and I want it to go inside of that object and mess with it. Like I want to be able to say I want to go through the numbers of s and set s.nums at 0, plus it. That's what I want to be able to do right now. I cannot do this right now, right? Because it's private. Any statistician object, this is just a function right now. This is private. Inside of that class, it will not compile. It's not happy, all right? Let's say I trust my coworker who's making this function. I want to give them access to the private stuff of a statistician object. You can do that by marking that function as a friend. Isn't that a cute metaphor? I love that so much. It's a friend of the class, and so it's allowed to look into it, all right? That lets you access private stuff, all right? The class itself is where you say who's your friend, all right? So it's kind of like a one-way friendship. But what you do is you take the declaration of that special function that you're going to let people access member variables for. You put it right here, more or less. So you say take its declaration, and then you say friend in front of it. And what that's saying is there is going to be a function later, C++, called this. It is my friend. It's allowed to use my private stuff. All right. So this is just marking, hey, C++, it's okay for this function to access my private member variables. That's such a, I love that metaphor. It's so cute. All right, so it's my friend. And now suddenly this line compiles. I'm allowed to touch private member variables of the S object, whatever was given to me. All right, and so let's do it right. Let's go through it as a loop. Let's be like for int I equals, just go through indices just to remember how to do that. S has a nums vector that I can access now because it's private and I have access to that. Go through that size, I++. Just like s.nums at I++. All right. And then also, whenever you go through, here's what our, whenever we want to add one to every number in our statistician object, what does that mean for all of our member variables? The count didn't change. We didn't add any more numbers. We messed with the nums already. Does current max change if I'm adding one to everything? I think it should, right? What should it change to? If the old max was 42, what must it be now?
43.
Yeah, so whatever the max is, it's one more now. S.current max plus plus. Yeah, so that makes sense. That's what you got to do. And now I can run that, and it's happy. So before I output something, let's call it. Let's be like, before I do all this stuff, let's take what we got and like add one to every number. One on S. Give it that S object. So it's taking it now, and it's messing with stuff. This one. Okay. So now if I compile it and I give it, let's see, I'll just give it 1, 2, 3. 1, 2, 3, -1. So it still had the 42 in there, but now it's 43, right? So now the numbers are 43, 1, 2, 3, 4. The maximum is 43, and I trust that this is the right average now. Okay. Does that make enough sense? Questions about that? It's like, it's a function. You can give it access to your class if you want by marking it as a friend. Like this, inside the class. All right. You ready for the last topic of the day before our break? There's a lot of words that I have to say. I apologize, but we're almost there. So I just want to talk about testing, because testing is very important. We want to make sure what we just wrote is correct. Like, how do you know? So we will make a bunch of test cases. That's one way to do it, and that's what we're going to do in this class. And that's just going to convince ourselves. Like, the more test cases we make that are varied, it will help us trust our program that we wrote. All right. So what a test is you've made some code. You've come up with a scenario in your mind. You write some code, predefine it, and you run the code in your mind and make sure that what happened in the code, like in that test that you also wrote inside the program, matches, like the result is the same one as you running it in your mind, whatever you got in there. Okay, so that's important. You predefine things, like set it to 40, like add 42, then 1, then 2, then 3 in that order, and check some things that should have happened. All right. So for example, here's like a test. If I run these 2 lines of code, what should have happened is like s.nums at 0 should be equal to 42. The count should be 1. All these things I should be checking those, right? That would prove that I did it right. Yes. That's the goal. So like this should be my S object. This is what it should look like. Like nums should just be that one number 42, because that's what init does. And then you also got count and max and all those things, and you can look at those 2 and check. Okay. So that's what a test is. Like you come up with a scenario and you make sure you got what you expected. Okay. So yeah, let's do a test, and that will be it. And then I'll give you a break, and then we'll come back and we'll get on the server and all that. So let's see here. I would like to make a little test. Let's make a test for getting the max. All right. So here's my scenario that I've come up with. Let's be like, let's make a new statistician object, call it S. We'll call init on it. We will get the max right away. It should be 42, right? That was the one thing that init puts in there, right? And then we'll add 43. So it's like a few tests in one. Then we'll add 43. And then get max should hold 43, right? Because that's the new number. That's bigger. Add 44. Now it's 44. That's the new max. If I add 0, though, like an incorrect implementation would be like, take the last number. That's the max always. So far, there's no difference. Now let's add 0 and make sure the max is still 44. See how that's like, now it's varied. It's making sure that it's really doing the right thing. So that's a test. Let's make that test. All right. The standard way of making a test is to use a function that like does a little if statement for you that checks a Boolean condition. So that's called, lovingly, assert true. I want to assert that something is true or not. So it's called this, void assert true. And it takes a Boolean that you want to make sure is true. Like you're asserting that that is a true thing. And it takes a description of the test. You'll see this a lot in our labs. And so I need the string library. But what assert true does is just like, you give it a check, something that evaluates to true or false. And it's like, if that check is true, so like if B is true, a shorter way to say this would be just like if B, right? Because like if that's true, it will become true and run the body. So if B is true, then see out that the test passed. And then give the description so you know which test it was that passed, just in case you had multiple. And then otherwise, if that B wasn't true, that thing that you were hoping was true, that you were asserting would be true, then it really failed, right? So that's what assert true is, and let's use that to build our max test. So usually a test is like a function, and the entire test happens here. So my goal is to do all these things. I'll make those comments so I don't forget. Dun, dun, dun. Oh, I hate this new laptop. Yeah. Can I do it with this one? No. Weird. All right. I guess I can do it this way. I just want it to look pretty. All right, so I need to make a new object. I'll call it S. And I want to call init on it. And then getMax right now should return 42. So what is the condition that should be true right now? If I say s.getMax, it better give back 42. So that's going to be my test that I shove into assert true up here. It takes that Boolean as the first thing. It's like assert that this is true. Assert that this evaluates to true. And here's the test. It's just like, I don't know, getMax equals 42. Some words to describe what you just did. Okay, so that's how you run it. And then, all right, let's add some stuff. So like s, add number, 43. Now the max should be 43, right? That's my next test. I'm checking that. It'll either pass or fail. Add 44. Check that the max is now 44. And then if I add 0, that should not change the max. Should still be 44, right? So those are my tests, and you kind of see how they're going to work together in that order. Just like I have this scenario in my mind, I know what should have happened, I'm making sure that all those things happened. And so, yeah, that's a test, and we can ask it to run by putting it in the main function somewhere. Just put it down here. Test max. And that'll be that. So you got 1, 2, 3. Those don't matter with the test, at least. And then it runs the test after all that, and hey, they all passed. If they fail, you go back and be like, all right, why did it fail? Sometimes you write the wrong test. Like the test could be incorrect too. But usually, if you think about it hard enough, like it's going to work out, all right? So does the test itself make sense? You got your scenario, you're checking, making sure that what you expected to see really did happen. Okay. So with that, I can finally stop talking for at least a little while. It's a longer lecture for the day just to get us all in the same spots because I don't know where you came from. And so now we have a break. All right, so I'd like to give you a break. We got about, we can have a 10-minute break, I think is the standard amount of time. So please come back at 4:56. We won't have a ton of time to talk about the class server, but we will have some time, and I'll get it recorded so that you can work on it at home as well. But I want to get you on the servers after the break is over, and that will be my job until the end. Okay, so let us talk about, like, this is now the lab time during class. Usually it will happen a lot sooner. Just today is a longer day. So what I would like to do is get y'all on the class server. So this is a place that you will be doing the bulk of your work in during the semester. This is where you'll be programming. It is server.lottensclass.com is the URL for it. And the way you connect is either you get on PuTTY, like these computers should have PuTTY installed if you're on Windows, or if you're on Mac or you have like, you want to use the terminal on Windows. If you have Windows terminal installed, like I can show you how to do it that way. But let me just do PuTTY because I know that all these computers have PuTTY. All right. I'll show you what to do. And by the way, your username is the exact same kind of username as the class website. Same password as well. the same default password. If you have not gone on the server yet, your password is still your username. Changing your password on the class website did not change on the class server. They just have the same defaults and the same username at the start. Okay? So, yeah, when you log in, let me show you how to do it in PuTTY. Just really quick. Boop. Oh, apparently I don't have PuTTY installed. Let me install it.
Oh boy.
This is a new laptop I had.
Oh boy. Actually, if it happened almost immediately.
Yeah, I'm forcing you. When you log in, I'm forcing you to change your password. There's no getting around that. Huh?
Does it keep out?
I don't know what's happening. Oh, there it is. Sorry. Cool. All right, now I have PuTTY installed. It's a new laptop. I had to do it. Okay, so what happens when you open PuTTY? You say where you want to connect. Let me zoom in. And we want to connect to server.latinsclass.com. That's the name of the computer. Port 22 is correct. SSH is correct. And then you just hit open. You can like save all this stuff for later. When you hit open, it's like, do you trust this computer if it's the first time? It's like, yes, accept. I trust it. And then you say who you want to log in as. And I accidentally did something very wrong, and let me fix that. But I was trying to change the font size just really quick. 10-point font is not what we need right now. There. So let me do all that over again because I accidentally typed something by clicking the right click button. So close that. So open PuTTY. It's server.latinsclass.com. And then, why did it not change the font size? Whatever. All right, I'll just zoom in. Who you want to log in as? It's your last name _ student ID, just like for the class website. I've got a test student. I'll do that one. Hit enter, and then it starts asking for your password. All right, it starts asking for your password, and you type it. It's the same as your username if you haven't logged in before. And you will not see anything. There's no little circles. There's no little stars. When you start typing, it's still getting it. You type enter when you're done, it'll get it. And the very first time you log in, you hit enter, it will force you to change your password. You type it all over again. You say current password one more time, then the password you want. You gotta type your current password once more. Just follow the prompts. And then it will kick you out, and then you'll log back in with the new password that you just set. But once you get to the cow, everything is nice. All right? If you see the cow, everything's happy. Okay? So I'll come around and help anybody who's having trouble with that. I'll show just how to do it on a Mac in just a second. But if you want to log out, the graceful way is to not use the X. That's like jarring to the server. There's an exit terminal command. You type exit, hit enter. That logs you out properly. All right, so let me just write that down. So to log out, you say exit the terminal command, or you could type Control-D. Control-D sends something that is kind of equivalent. So you won't see stars. It'll force you to change your password, stuff like that. If you are on a Mac or you have like Windows Terminal installed, you want to use PowerShell or something, or you installed Windows Subsystem for Linux, this is how you connect if you're on a Mac. You open up the terminal program on your Mac. You have a Mac terminal, and it's already on there. And so you'll go and open that. It's in your Applications Utilities folder. You can just search for it. And then there's an SSH command to connect to another computer. You say SSH space your username, which is last name _ student ID, and @ just like it's an email, and then the name of the computer you want to connect to. So at server.latinsclass.com. Let me show you it that way. So if you're on a Mac, you do it this way. You'd be like SSH, my username, at server.latinsclass.com. Hit enter. It'll get you on there eventually. It'll force you to do all the same stuff. Type your password. Force you to change it. And then you do have to pay close attention if you do it this way, if you're on a Mac. Once you log out of the class server, you're back on your home computer's, your local computer's terminal, where you'd have to re-log in with SSH again to get back on the class server. Okay, I hope that makes a little bit of sense. So like that's how that works. That's how you get on. So everybody, let's try to get to the cow. Yes, it is across the internet. This server, by the way, there's a little bit of lag. The server is located in Germany. So
We'll see if we get her.
Do you guys think that I have control over when the data center in Germany has a power outage?
No.
I do not. So we should be saving our work very often. So yeah, let's all try to get to the cow. I'll come around and help. Is there anybody who's having any issues that I can help with? Yeah. If you took a past class with me, and you're on a Mac, your terminal might be yelling at you right now saying, I think something is nefarious. No. Yeah, so here, let me type the magic on the one on top. Yeah. Enter that so you can save it still, but it's not. That's what we needed. Now we can say, yes, we trust this thing. But yeah, it's a brand new account, so still using it. It's set to your password set to using anything added possibly. If you can't seem to get past the password change, remember that the first thing it asks a second time is your current password. Don't just type the new one you want, because it will fail. All right. Well, while we're doing that, I have more things to say while there's time. We're out here at 5:20. Yeah. On Tuesdays at least. It's different on Thursdays. So okay. The next thing I want to say while you're doing all that is you do not have to do your work on the class server if you don't want to. I encourage you to learn it. Like, it's something I'm required to teach you. It's like, it's going to help you a lot in the future. Like, you cannot avoid the terminal, no matter how hard you try. So it's worth learning it now and getting good at it. There are ways, though, to work on your local computer in a graphical way if you want. That's one option. I encourage you, though, I can help you get and do your work on your local computer on the terminal. I can get you a Linux terminal on your computer, or if you're on a Mac, you already have an equivalent thing. Okay, so I can help you with that if you would like. And alternatively, and then if you do your work on your local computer, then you just need a way to copy files onto the server and back and forth, because you only can turn in stuff on the server. So you got to get the files there eventually and also get them out to start. So there's a cute little program called CyberDuck that helps with that. I can show you how to use it. And then also on Windows, there's one called WinSCP. And there's ways to copy stuff back and forth. And maybe you're going to want this at the end of the semester anyways to get all of the stuff that you've done. So yeah, that's what I wanted to say there. Is there anybody who is having trouble still that I can help before I move on?
It's just not.
Okay, yeah, if there's no internet, I think you might have to just like move to a different computer. Give up. Fair enough. Who was having trouble? Was it you? Yeah. Okay. Same exact stuff as it was on here as you did for the class website, but it's still set to your username if you haven't logged in. Yeah, so perfect. Just your username all over again, hit enter. Nice. And so it's current password one more time. Type your current password. It's forcing you to change it. It wants the current one more time. And then you type the new one twice, what you want now. And then it kicks you off, and now you log back in. Same process, but with the new password to get you. Anybody else? And then I'll say one more thing for this. Yeah. It's unhappy because the server has a all right, so I'll come back around if there's still more issues, but I just want to move on for those of us who are on, so we have time to get to everything. It's all recorded one way or another. So I just want to give you just a crash course to the Linux terminal, also called the shell. So when you get on the terminal, if you've already learned about this, you can ignore me. But for those of us who have never seen it before, I just want to give you a crash course. It's going to be recorded. You can come back to this. So very, very quick introduction. When you log in, you're plopped into a folder. There's always a file system at the end of the day. You're plopped into a folder with a little squiggle. It's called a tilde character. And this means there's always a concept of where you are right now. On the terminal, I am in my home folder. Everybody in the class gets their own folder to put stuff in. You can say pwd and hit enter to show like what the full directory is. It's like there's a root directory, there's a home folder inside of that, and then there's a folder with your username, and that's where you work on your stuff. You have access to that, nobody else. Okay, so that's where you are by default when you log in. You're in your home directory. This is its real name, but its shorthand is squiggle tilde. Okay, short for your home folder, and you can see where you are. Like you can see what's in your current directory wherever you are right now. There's always a concept of where you are with ls to list the current files. All right, ls to list the current files. Your ls should say nothing at all right now because it's a blank slate. You're brand new. So let me get back to that. Blank slate. That's what you would see. All right. PWD again shows you where you are. If you would like to make a folder, it's makedir. Like I don't know, folder for my labs. Go in there, or folder for like temporary things. Type ls. Now I've got two blue things, two folders that I can go and work inside of if I want to. So like let me go inside of the temporary folder. I'll say cd to change directory. Cd temp. Hit enter. My prompt changed. PWD tells me I'm in a new spot. I'm inside of one more folder, right? Inside of my home folder. And now I can work on stuff. I can edit files. I can get back to where I am. I can make more folders inside of folders. Before I show you how to edit files, to get back to your home folder, there's always a trick. You can always say cd tilde, wherever you are. That's always shorthand for your home folder. Get back to where you started when you log in. Okay? That's always there. You can get back to where you were with temp, cd temp. And if you want to go out, like you made a bunch of folders, you just want to go one out, that's ... is shorthand for parent directory, one away, one out. So temp was inside the home folder, so that cd ... took me back to the home folder. Okay, so yeah, let me go back inside of temp. So that's the game you play to move around. Cd inside of something, get back to the home directory with cd tilde, cd ... to go out one if I need to do something. But here I am inside of my temp directory. ls shows me that there's nothing there yet, so it's a brand new, fresh thing. I would like to just make a hello world computer program just quickly, compile and run it for you, just to show you the ins and outs. There are graphical ways to edit files, right? Then there are also terminal ways to edit files. One, the easiest way, if you've never done it before, highly encourage you to learn the cooler way later, but for now, it's called nano. There's one called nano, and that's just like a simple way to edit files. You say nano space the name of the file you would like to edit. So I'll make a new file called hello.cpp, and that's the command to say, hey nano, I want to edit a file. Here's its name in my current directory. Hit enter, and it plops me into this program. This is called nano, and you just start typing, like include iostream using namespace standard int main. It shows you pretty colors, but that's about as good as it is. Like you can't use the mouse. You got to use the arrow keys. You can tab over. Now it goes too far. I'd rather use spaces. See out. Hello world. It's trying though. It doesn't keep your indentation. It's kind of disgusting, but it's good enough for now. So that's one way to edit files. You say its name in nano, and then when you want to save and quit, it's these things at the bottom tell you what you're doing. It's this character stands for control. So I want to say control X to exit, and will ask me if I've made changes if I want to save. So control X. Do I want to save what I changed? Y for yes. How do you want to call this thing that you changed? Well, I just want to keep the file name that it is. I don't want to write a new file. I want to just overwrite the current one. So just hit enter. It's already filled out. And now if I do ls, there's something there. It's not blue because it's not a folder, but it's a file. And you can always go back to it by saying nano its name again. That'll plop you into where it was. You got your changes there. Nothing you don't expect. And it's always control X to save and quit. If you didn't make any changes, it won't ask you. But yeah, now it's there. And you can compile and run with G++. G++ hello.cpp -o hello. And that makes a green thing, which is runnable thing. Hello./ it's a // a dot and a slash // to run a compiled program, an executable file, and bam, there it is. All right. So that more or less are a lot of things that you'll want. All right. So let me give you this screenshot so you can look at it later. Why is it there twice? I don't know. But, and I'll go back to this slide because that's probably where you want to look. Nano is disgusting. It doesn't even let you use the mouse. So there's a better editor, and it's called Vim. That's the one I used in class today. That's what the cool kids use mostly. It's probably one. There are two competing ones. I don't want to get into the holy war between them. But Vim is like a very popular terminal-based text editor that it would only help you if you learned. All right, it will make things better for you throughout the semester. And so there's a way to learn Vim. Vim is the same as Nano. You say Vim the name of the file instead of Nano the name of the file. But don't try it if you have not done the tutorial, because the meme is nobody knows how to exit out of Vim. All right, and that will be you if you don't do the tutorial first. So first of all, the mouse works. I can use my scroll wheel. I have line numbers easily, and like it keeps the indentation. Just like the world is a nice place inside of Vim. All right, so I encourage you to learn that, and the way you learn it is like to actually edit a file. You say Vim space the name of the file, just like you did for Nano, but it's called Vim Tutor. There's a command called Vim Tutor that you can run. That is the tutorial for Vim. It'll plop you in there. You just start using the arrow keys like in Nano to scroll as you read the tutorial, and it'll teach you the Vim way to do things. The very first thing it teaches you is how to exit. All right, so keep that in mind. Vim Tutor is your friend once you want to get advanced, and like it can only help you. It'll make things go by faster. Okay, so yeah, do that once when you have time. And I think that is all that I wanted to record for the day.